is Abdul Rahman. I'm a lecturer at a public university in Kenya. I deliver lectures in computing and informatics. In our last lesson, we discussed about the reloc function. We had seen that the reloc function actually reallocate memory. Specifically, it reallocate insufficient memory which has been allocated by either a malloc function or a calloc function. Today, we are going actually to go to the end of a series of memory management presentations, and into that particular series, we are going to talk about the last inbuilt function which is provided by C program, and that is what you call a free function. So into that particular journey, we are going to talk about what is actually a free function, a syntax, and basically we are going to go to dev C++ and implement. So let us start on that particular journey. So what is a free function inbuilt into memory management in C programming? So we are saying basically a free function actually it is used to deallocate memory. So it is used to deallocate memory, and this particular memory basically it is actually the one which has been allocated using either malloc function or which has been allocated using what you call a calloc function. So it is very good practice to deallocate memory, especially programmers who are using programming small devices such as mobile programming, whereby small devices memory it is of utmost importance and they have got small memory. So in this particular device it is very important to understand and to manage memory at the end of the day. So that it is what you call a free function, that it allocates memory allocated by either malloc or calloc. So in that particular order, we are going to go to the syntax. So the syntax is very simple and very straightforward. Just writing up the word free and then putting up actually the pointer inside. So that will be basically the syntax of it. So how do you apply this particular syntax? Let's see. For example, if you have a pointer and that particular pointer, let's say we typecast it and we're using up a calloc, and in the calloc, so you're going to have what you 5 continuous block, and here we'll have a size of our integer. So this is our size of an integer. So basically let's conceptualize up the same. So when you conceptualize P, you'll have actually 5 continuous blocks. So this is 1, 2, 3, 4 and 5. So these are the 5 continuous blocks, and each block will have actually 4 bytes. So the whole block will have 4 times 5, which is actually 20 bytes. So basically, so this will have our block 1, block 2, block 3, block 4 and block 5. So when we are going to apply in this particular block our free, so here we can say now our free P. So when we apply our free to the pointer, so this what will happen, it is at the end of the day all these particular blocks they are going to be free, and our memory P will be released. So basically this what happens when use up a free function. So on that particular note, We've explained what is actually a free function, that it allocates memory, and basically it allocates specifically memory which has been assigned or assigned by malloc or a calloc function. So let's go to dev C++ and see if actually we can demonstrate up the same. So here in dev C++, so we initialize some pointer, so pointer p1 and another pointer p2, and we have up actually the num n to hold up the number of elements. So basically here we are saying printf, and we are saying enter the number of array elements. So a user will enter the number of array elements because we want to assign them dynamically, and we're using up our scanf to capture our n. So here we are going to use %d because it's data type of integer, and we're putting up ampersand n. So that is where we actually capture it, and basically now we are assigning memory allocation dynamically, and here basically we're using up here we are using up the malloc function. So our p we have typecast it, so malloc, so using up malloc, and the syntax of a malloc, it is actually what we have, it is n times the size of the type, and our type was integer, so n size the type of integer. So we have allocate our p1 there, and then we want to allocate our p2 using up calloc, that is continuous. So there we have it, int, we typecast it, and then we are calling it a calloc, and a calloc we are allocating continuous, so it will be actually n and the size of our type, so our type, it is integer. So actually we have signed it there dynamically. After signing up dynamically, we want to check actually has it been assigned or not. We're putting up an if statement, so we are saying if our p1 actually equals to null, and here you're using up the AND operator, and we're using up the AND operator where we have, so that is actually the and our p2 actually equals to even null, then do what? So from there we are saying then do what? Then we are saying printf and we are saying memory not allocated. So basically that's what we are saying, and then if memory not allocated, we are saying exit that particular program. And then from there we are putting up an else statement. So from here we are putting up an else statement, else do the following. So else, what are we going to do? Say printf and we are saying memory allocated or successfully allocated using actually the malloc. Memory successfully allocated using up malloc. And then from here, now we're bringing in, after that we're bringing in our free function. So now we want to free, so we are freeing what? We are freeing actually P1. So when after freeing up P1, which actually holds which was assigned the malloc function, we can write up another one that tell up a user now that so now from there we can say now the malloc function has been freed. So basically thus we want to write now the malloc function has been freed, and there we put up a new line. So after doing that, basically we want to go to the second part of it. Now we're putting up another message, and this particular message just simple printf, and this time what are we saying? We are saying memory successfully allocated using calloc this time. So memory successfully using up a calloc, and from there basically now we are using up, sorry, have to terminate. Using up now again, we are bringing up our free function, and this time what are we freeing? We are freeing P2, and P2 holds what? So P2 actually holds the malloc. So basically hold the calloc. So here we are saying printf, and what are we saying? Basically we are saying now the calloc function has been freed. So basically this is how our program will look like. We are using up, we are trying to allocate calloc and malloc, and after that we are using up the free actually to free those particular memory which has been allocated. Okay, now let's run this particular program and see how it executes. So when we run this particular program, we are seeing up here, actually it tells us enter the number of elements of an array. So on that particular note, we'll enter maybe 5, the number of array, and actually it gives us a message, the memory successfully allocated using malloc. Now the memory allocated has been freed after we have actually put up the free function. And then the next part of it say memory successfully allocated using calloc, and now the memory the calloc memory has been actually free using up the free again to free up the calloc function. So that was actually makes up the end of this particular session, and into our next session we are going to start up onto a series of sessions which we are going to discuss what is structure in C programming. However, don't forget to subscribe into our future sessions. For now I say bye. Thank you.